Okay. So we're gonna get started on this learner tutorial. Just for credit's sake, this script was adapted from Tanya Rogers, who is at UC Santa Cruz, and I think Noah, who adapted it from Umi Hoshijima, who adapted it from Software Carpentry. So if you've been to any kind of function writing workshop before, this material may look very familiar to you. And I wrote this with a lot of help from Juliette Verstein and Sam Chick, so thank you both for that. And I also, just like as an aside, learned a lot about the format of learner tutorials while I was writing this. So if you are interested in developing your own, the source code for that is on the first page. And a lot of that code is cribbed from Alison Horst. So lots of copy pasting happening here. Okay. So just to get you situated in the format, the toolbar is all on the side here. There are 5 major topics. You can navigate in on the bottom with these buttons labeled next topic. If you decide that you want to start over completely, you can just hit the start over button and it'll ask you if you're sure that you want to start over. We'll just say yes. And each section has a little bit of an activity or a chunk of code where you can type in that code, run it, and see the output. And some sections will have a little hint, so you can click on that hint if you're stuck and copy paste that code and run it. But obviously we're just going to go through it together. So please feel free to ask any questions. Go ahead and unmute yourself or type in the chat. Juliette and Sam will be monitoring the chat. And yeah, any questions before we get started? All right, let's get into it. So what do functions actually do? Functions allow you to do things in R. So using a function has 3 basic components. The first is the actual function. So it's always some word or term with parentheses. So anytime you're handling any kind of function in R, it's probably going to have something and parentheses. So the example here is mean. Oftentimes functions are named sort of logically. So mean, you might imagine, takes the mean of something. And the second part is the arguments. So whatever goes inside those parentheses. So mean takes arguments that are vectors of numbers or numbers themselves. So for example, 2, 3, 5, and 7 can be the arguments that go into mean. And then the function plus the arguments lead to the output. So if you take mean of 2, 3, 5, and 7, what you're going to get is 4.25. So for example, we're just going to use mean really quick to calculate the mean of this data called, this vector called dat. So to do that, I'm going to type in mean. And oftentimes, if you're using a function in R, you'll see this drop-down menu with all of the possible functions that you could be meaning to type in at the moment. So you can click on that, or you can just open up the parentheses to indicate that that's the function that you want to use. And then I'll just put that in there. And then it disconnected from the server. What? We love to see it. I have no idea what's happening. Here's some inside.
It did it for me too, Anne.
Ooh, that's good.
There's probably too many people on it.
It's probably because we're all on it. Okay, well, okay. Can I get a thumbs up for everyone who got the code from GitHub or Google Drive? Okay.
It might be best just to demonstrate if people could sign off that on the server to see if that actually works. And then
Yeah, we can do
um,
that. I mean, we can, so there are a couple options. We can just switch over to RStudio, or you can all just basically watch me code in ASMR fashion on a learner tutorial. Either way. Compelling. Okay, great. Well, then in that case, I'll just wait for everyone to get off the server, and I'll just walk through this tutorial, and I suppose it'll just wash over you like a monologue of me talking about functions.
if this doesn't work, I think it would be appropriate to just switch over to R and demonstrate. Even if people can't follow along, I think it'll still be useful.
Yes, that is true.
It's weird though. I didn't know this was a problem, or could be a problem.
You know what? I didn't know either, and we all learn new things. Oh boy. The relentless burden of technology. Okay, so I'm just gonna switch over to RStudio.
It was a valiant attempt.
I tried. We tried. There were illustrations. I was pretty excited about it. Anyway, so functions allow you to do things in R. We're going to take the mean of this vector of numbers, and then it shows up in the console. We were able to successfully take the mean of that vector of numbers. I'm also going to zoom in. Okay. Another example is that plot is a function that allows you to make a plot, and the arguments let you customize that plot. So I'm just going to make some fake data to put into the plot, and then using plot, the function plot, the first argument is the x-axis of the plot, the second argument is a y-axis, and then when you run that, that should create a plot, and it does. Perfect. So functions are really the building blocks of most of the work that we do in R, and so you're probably familiar with them. But sometimes R doesn't have the function that you want, and that's okay because you can write your own. And the function called function lets you write a function. So the basic structure reflects function components. So you can call a function called your function called my function. And within the function argument, you will designate whatever arguments you want to put into your function. And then you will open up your curly brackets, and then within your curly brackets, everything that makes that function work goes in there. So let's say that there's some operation that you want to happen, that you want to have happen on those arguments. So something happens to the arguments, you store that as some output. And then at the end of your function, you'll always have this line with the return function. So return will just give you back what you put into it. So we're returning the output. So you have a function name, and then you're using the function called function. You put your arguments in there, and in the curly brackets are the operations that you want to have happen. And then at the end, you are returning some kind of output. Okay. So let's put that into practice by actually writing a function to convert temperature values. So the US uses Fahrenheit, but we can convert that into Celsius. And the formula for converting Fahrenheit into Celsius is C is equal to whatever temperature in Fahrenheit minus 32 divided by 1.8. And the opposite conversion is just F Fahrenheit is equal to Celsius times 1.8 plus 32. So we can write a function called f to c that converts Fahrenheit to Celsius. So this is the function that I'm creating, this function called f to c. And then again, using the function called function to create that. So function x, that means that my whatever argument that goes into f to c is going to be x. And then within my curly brackets, I have the operations that I want to have happen to x. So I am subtracting 32 from x, dividing that all by 1.8, and storing that as a temporary object called convert. And then at the end, I am returning convert. And that is it. So when I run this chunk of code, nothing actually shows up in the console. But if you look in your environment, there's now a subsection called functions. And if you click on that, that'll open up this separate script that that has the code for that function, which is really useful when you've generated a bunch of functions and you don't know what the hell any of them do. You can just click on that function name in the environment, and it'll show you what the code was to create that function. So now that that's stored in our environment, we can actually use it. So I'm just going to see what 78 Fahrenheit is in Celsius. So I'm going to hit F to C, and that shows up as a potential thing to autofill now. So I can click on that, or I can just complete it. And then the hover box, the yellow box, shows you what arguments that function takes, and it takes x. So I'm just going to put 78 in there, run that code, and as it turns out, 78 degrees Fahrenheit is 25.56 degrees Celsius. And now we have a function. Does anyone have any questions about that? The dollar signs are LaTeX notation. So it's like sort of this mathy thing. What is the value of using the name/return section? You don't actually have to split those up into two lines. You could just put all of this into here, and that could be your whole function. I just split it up for like ease of looking at what it is that I've written. So it's like a little bit more time, a little bit more space taken up, but for like personal readability, that's why I split it up. If there's a function with the same name, I don't actually know. I think that you can, the function that you write overwrites that other function. So if you were to just type in your function name, then like whatever operations would happen would be in your function. And if you wanted to use that other function, you'd have to name the package that it's in before you use it.
Also, Anne, when you were typing out F2, like _2, and then waited, it'll show you, like typically it'll show which package that functions from, but here when she types that in, it'll show that it's coming from the global environment. So you know that it's the one that you just wrote and stored there.
And how important is the indentation in R? Not super important. Your code is going to run regardless of indentation, but again, it's like sort of a readability thing, at least for me. Also, hot tip about indentation. If you're like writing a bunch of code and your indentation's all off, for example, you can highlight your whole chunk of code that you want to adjust the indentation for and hit Command I, and then it'll shift all of the lines over to where they're supposed to be, which is very
Magic.
nice. Yeah. Okay. Also, just as a formatting note, the curly brackets and functions are super, super important for making sure the code actually works. And you can save yourself a ton of pain and heartache when you're writing a function if you immediately hit enter a bunch of times after opening up your brackets. So after you're done writing your function, you can delete all of your extraneous space to make sure that you're not actually deleting all of your brackets. So if you would like to follow along, you can write a function called C to F. I just have it here. But again, I'll just like demonstrate how that sort of curly bracket thing works. So in R, when you open up parentheses, brackets, whatever it is, it'll automatically fill in your closing. So here, when I open up those curly brackets, it'll automatically fill in the closing bracket, and I just like hit enter a bunch of times to give myself a lot of space to write that function, and then delete all of the extra space at the end. So now I have this function called C to F. The function takes the argument x and then makes this conversion x times 1.8 plus 32, returns that converted value. And now again, that function shows up in our environment. If I want to see the code to generate that function, just click on it and then it pops up in another window. And now I'm going to try it. So C to F, like Sam mentioned, so when I start typing in that function, it shows up as being in the global environment. And then I'm just going to see what 26 degrees Celsius is in Fahrenheit, and it is 78.8. Right. Any questions before we move on to slightly fancier? I want to turn on the rainbow parentheses right now. What is happening?
I think you have to have the newest RStudio version installed. Sorry.
Gosh. Okay.
But they're really awesome.
Something that I will do after this call. All right. So we can make these functions as fancy as we want them to be. So let's say that we want to convert between Celsius and Fahrenheit, but we don't want to have separate functions for each. So if we want to do that, we can write a function that uses conditionals, which basically tell our code to execute different actions depending on whether a condition is true or false. So to do so, we use if or if-else statements within our function. So basically, in order to like wrap our heads around this, we can think of the functions that we just made, so F to C and C to F. We can put all of the components of those functions into one and designate arguments for switching between each conversion. So you're basically compressing a bunch of different operations, which is the temperature conversion, into one thing, which is the function, and then calling the right conversion every time you want to use the function by using those arguments. So I understand that I just like said a bunch of things. It's a little esoteric, but we'll look at the code to see how that works. Here, we're going to use the function structure to make a function called temp_conv that converts between Celsius and Fahrenheit. So inside the function, we're going to use if statements to switch between all of those conversions equations. So the if-else statement basically tells R to do some basic operations based on what you want or what you've typed in. So if the inputs of your function are Celsius and Fahrenheit, then use the conversion from Celsius to Fahrenheit. Else, if the inputs are Fahrenheit and Celsius, then use the conversion for Fahrenheit to Celsius. Else, if the inputs are neither Fahrenheit or Celsius, then return an NA and give a warning message to let us know that something's wrong. This last step isn't necessary to make the function run on its own, but it's super important to help us troubleshoot any problematic code that we might have. So that last warning statement is really important. So here's the code for our new function. So again, we're creating this function called temp.conv, and then using the function called function. Our arguments are from, to, and x, representing the temperature. We open up our curly brackets, and then everything on the inside is our function here. So if the first chunk here, if our from is Celsius and our to is Fahrenheit, then we're going to convert from Celsius to Fahrenheit. Else, if our from is Fahrenheit and our to is Celsius, then we'll convert from Fahrenheit to Celsius. And then if the inputs don't match either of the first two conditionals, we're going to give a warning and return an NA. So else, notice that it doesn't have a second if because it's the last thing. Else, warning, the inputs provided from blank to blank are not as expected, double check your spelling, and then it'll return the NA. And then the last thing is that return line to return the converted value. Any questions about that function structure? Conditionals? Anything at all? Is warning a function in R specific to writing functions? I do not think so. Let's check that in the help page. Sam, do you know?
You can add warnings into any chunk of your code. It's like adding a print statement somewhere. And I pretty much only ever use them for writing functions. But instead of printing just like character strings, you can print warnings, which allow you to add in like arguments. Like if you look at the example here, Anne has typed out this character string that says the inputs provided from equals, and then the from argument. So it'll add in whatever the user typed in for the from argument. So it'll just kind of give you some more information. And it prints it out in like different color than the white text that you get from the print function. There's also errors, which I don't use very often myself. I don't actually know a whole lot about how to use this effectively, but I think they're useful for warnings are at least really useful for function writing.
And yes, I am returning convert. It's the last line in the function there. For like the missing, like here. Just missing quotes. Oh, that'll show up when you actually run the function. So I will demonstrate that. So let's try a bunch of ways to break this function first. So let's do from Celsius to Fahrenheit 25, and then I don't have quotes around these. Let's just run that. It'll just pop up in the console, this error message, object Celsius not found. And that's because anything in quotes, not in quotes, R assumes is some kind of object. So that's sort of like built into the way that R evaluates statements.
So my question was just more of like, it's probably like not, doesn't really make sense right now in this example, but it's just like, is there any way to personalize this error, just saying like, you forgot the quotes? And instead of having like the pattern, like the normal default error message, just out of curiosity.
Mm-hmm. 'Cause You know, there must be. I think one of the ways that you could do that is uh, put that warning chunk of code at the top, and the conditional could be um, whether or not your argument matched the class character. So characters always have quotes around them. So you'd evaluate a conditional asking whether or not your argument was a character. And if it wasn't a character, then you could give some customized error message saying, look out for your quotes or something like that. Does that answer your question? Okay. All right. So I'm gonna put this back in quotes, and then I'm going to run that. And now we know that 25 degrees Celsius to Fahrenheit is 77 degrees. Are double equal signs different from single equal signs? Yes. And I'm not going to give a particularly eloquent explanation as to why, but the double equal sign is a matching sort of operator. So it asks if the thing on the left matches the thing on the right. And the equal sign is, well, is used in many different contexts, but one of those ways is to basically assign variables. So they are different, and they're used in different contexts. Does that answer your question?
Yes, thank you.
Okay. All right. So what if we supply inputs that aren't Celsius and Fahrenheit? Let's say aka I am lazy, and I don't want to write in from Celsius or to Fahrenheit. That'll pop up our custom warning message. So the inputs provided are not as expected. Double check our spelling. When I was writing this workshop, I misspelled Fahrenheit throughout the whole frickin' script. So many things weren't working. But if you want to supply these shorter arguments, you can put those in using a different operator. So if you want to incorporate different types of arguments into your function, you can use the OR operator, which is these two bars right here. They are above the backslash button. They're the same button as the backslash, which is above the enter. My two brain cells. Okay, so again, we still have the same structure that we did before, temp-conf with these three different arguments, but in our if-else statements, we have these OR operators. So in this first chunk here, if our from is Celsius or C, and to is Fahrenheit or F, then we use conversion from Celsius to Fahrenheit. And then in this next chunk, if our from is Fahrenheit or it's from F, and our to is Celsius or to C, we convert from Fahrenheit to Celsius. And then if our from and to don't match any of our expected inputs, we'll give a warning again. And then at the end, we'll return our converted value there. Any questions about the OR operator, how it's used? Any reason I use double, not single? I do not know, y'all. I have always used double bars. And I looked this up, and then there was a lot of programming language discussion, and then my eyes sort of glazed over. So does anyone have a good explanation for why one would use double bars instead of one?
I'm not sure if this is correct, but is it when you use the double bars and the and, it like doesn't work? Like if you just did from Celsius or C, it would work, but now that you have like that as a chunk together and then the Fahrenheit and the F together. Because I tried to write something like this before without the double bars and it didn't work. So I
Hmm.
wonder if that's what it is.
Okay. So you use a double when you have a. Yes, that could also be that. All right. So you use a double when you have other operators around.
Maybe. Don't quote me on that.
That sounds right.
Can you just always use the double then?
Yeah, I always use the double, but I wonder if there are other circumstances where using the single is more appropriate. And then how to use 3 dots in a function. I am not sure. Do you mean like sort of filling in arguments? Sam, did you have?
I was just going to ask for clarification if possible.
Okay. Hi. Thank you very much. Yeah, the question is sometimes, and I didn't understand this, if you don't like extra argument or something like this, you can put 3 dots in the function while you are doing this. I don't know if you heard about it before. Thank you.
I think I know what you're talking about, and I'll try to find an example of like a pre-built function, but I actually have no idea how to build that myself. So we'd have to look that up. Let me see.
Yeah, I am not actually sure how to build that in either, but thanks, Sam, for doing that. Yeah, I mean, this is just an example, but I'll just give an example from like when I'm writing functions for my own work. So I use a lot of data from these ecological research sites with like 12 different sites and a bunch of different species. And sometimes I want to create plots or filter things by site, and sometimes I want to filter by species. So I'll use the or operator to designate like I want to use a site or I want to use a species to do the same operations, but I just have a different use for that particular operation in different contexts. So that's why I would use the or operator. Okay. Any other questions that I can answer before we test this out? Okay. So I'm just going to run that whole chunk of code. I'm going to overwrite our old function. And now we can try the function with our new arguments. So again, from is C, 2 is F, and then let's say 38, hit that, and that's 100.4. Yeah, absolutely. So I'm going to go over the warning message again. So this warning message comes at the end of all of these conditionals. So the first thing that the function is going to evaluate is whether or not those conditionals match what it is that we've put in these if-else statements. So is the from Celsius, C, Fahrenheit, or F, or is the to Fahrenheit, F, or Celsius or C? So so it'll sort of evaluate the truth of those conditionals in those if-else statements. And then if none of those are true, then it's going to pop up a warning. So the way that this is written, the inputs provided from blank, and then the from here corresponds to the from that's in this from argument. Quote, and to quote two, so the two here corresponds to the two that's in this argument, are not as expected double check spelling. So it's with this warning sort of makes this expression of characters based on the things that are in quotes and the objects that are stored within the function. And yeah, so the commas are necessary for separating the different parts of that expression. So this is the first part, that's just a character. And then from, this is the second part, that's character, and then to, and then this is the third part. So the double quotes designate like, here's a part of characters, but actually what actually shows up is what's inside the double quotes. And you could also do that. So the reason I'm writing from and to and sort of trying to delineate that clearly is because I get confused when I write in my own functions. But this takes things in the same way that other functions do in R. So if you just wanted to have that, then that would still work. What a lot of times when we use functions in R, we don't say like explicitly what arguments we're using. And the way the function sort of runs is it expects a certain order for each argument. So you don't actually have to say from and to every time.
But and if you like did specify the arguments, could you do it in any order?
Yeah, let's try it out. Let's say that I want to do that. I don't actually know. Let's see. Yeah. So you could do it in any order that you wanted. But if you do actually want to do that, then you do have to explicitly name the arguments that you're using.
Sorry, I'm still a little confused about that warning message. So the commas you said are necessary, but the commas are within the quotation marks, right?
The commas are outside of the quotation marks. So maybe I'm going to split this up into different lines. So there are 5 different parts of this warning message.
I see. Okay, that makes a lot more sense. Thank you.
Yeah. Any other questions that I can answer?
Yes, please. Sorry. The quotation mark, if you look at them, they are not double, like single, then double, double, single. Why is it like this?
Yeah, so the warning message is, so it's an expression that's strung together from what's inside the double quotation marks and all of the rest of the things that are separated by commas. So I'm just going to try to pop that up. So if you look at this warning message, it's the inputs provided from C to FA are not as expected double check spelling. So if you go back to this code and look at that, it's the first part that's inside those double quotes, the inputs provided from single quotes, and that shows up right here. And then your from, which is right here. And then again, what's between the double quotes, so there's that single and to equals single quote to, and then you have this next expression, which is single quote within the double quotes.
You don't need to include the single quotes if you didn't want to. It's just how we chose to express that message.
Mhm. Any other questions that I can answer? Okay, so now we can write our own functions, writing practice. So hopefully, and if you're following along in the code, this is a, as we call it in class, a think, pair, share activity. So you'll think about it, you'll pair up with other people, and then you will share what you come up with. Or I can just talk through what we are doing. If you have the template markdown, there's a bunch of code below this blank chunk that is basically how we write that function. How do I think about what should be a function? Yeah, so I used to never write functions for whenever I was working on stuff. I would just like copy paste my code and like change arguments around to fit what I needed it to do. And I just did that enough. I did it too many times, and then I just decided to try to figure out functions. So I think the 3 times code rule works, but in my case, it was more like the 50 times code rule. But it is whatever works for you. I will say that functions have really streamlined my workflow when dealing with these big data sets that I mentioned. And also, if you're generating a lot of figures for your work, sort of making sure that your aesthetics are consistent throughout your whatever paper manuscript that you're preparing, functions are really helpful for that. So if there's any situation where you want your outputs to like stay consistent, then a function is probably a good tool for you to use.
Side note, I'll drop the link in it, but we did a workshop for data viz, and I think you wrote a function for producing figures, right? So I'll drop it in there and then you can look at it and it'll be another example for like how to use it.
Say another time, once a situation that's come up recently and some of the stuff I'm working on now is I had this really, really big for loop, which for loops were already like it can be intimidating on their own. And it just got to be like a couple hundred lines long, and it's difficult to figure out where problems are or even just navigating through that much code in general. And so one way that functions were really useful in that situation was to break out different components of that for loop, store them in their own separate functions, and then you can just call those functions in that for loop so that it really condensed it. It took like, I don't know, somewhere between 300 and 400 lines of code and shrunk it down to like less than 20 because I just kind of subsetted out parts of that into discrete functions. So that's another way I think it can be really useful.
Any other questions we can answer? All right. So,
Oh, sorry.
yeah.
I'm sorry, I
Go
just
ahead.
keep thinking of these questions as
No,
you start
no.
talking. But you're talking about kind of like shrinking down your code. So you're writing the function, the code for the function, defining the function within your kind of workflow code.
So there are a couple of different ways to do it. You can do it as you've just said, so define the function within your workflow. What I have sort of transitioned into using is having a separate script in my project directory that's just all of the code for the functions that I'm defining. And then in the workflow at the top, I use the source function. So source takes the argument that's like a file path string.
Yeah, okay, gotcha.
Yeah,
Thank you.
so you can do that as well. And I have personally done that more. Well, functions a lot when, yeah, absolutely. Running a bunch of models on different subsets of data, um, that is a common use of functions on my end too. In this case, is my if-else statement used only in case the user inputs the wrong thing? Yeah. So this sort of goes back to the question that was asked before, like, can we get a custom error message for an input where the thing isn't a character? So the conditional statement is like, is the argument a character? If that's true, then do all these operations. If not, then return that warning message. And yes, if you write tests for your code, a function should be written so that it's easy to test. I believe the package test that is what folks use to test their functions, but I have not used it before. I think testing functions is super important, especially if you want to like publish all of your functions in a package for others to use. So testing your functions is definitely important. Is the if-else structure necessary, or is it more so good practice? Yeah, it is more like good practice. So you wouldn't be able to have a warning message if you didn't have an if-else statement, basically. So the warning is sort of a way for us to troubleshoot whether or not, or like why our code isn't working. So you could just write this whole function without that. And it would probably still run. It would throw errors if it didn't run. But at least with a warning, you've written yourself a note basically about why it might not work.
The warning is especially good if you're going to be sharing your code with somebody else. So like you might know exactly what you did wrong, but somebody else might not.
In any case, there are a couple of examples of, well, this is sort of another function that one might use to write an expression. This data cleaning function is akin to the kind of stuff that I personally use functions for. So processing data, analyzing data, things of this nature. So you can definitely hopefully refer back to this code if you would like. This second function relies on the pipe operator, which is in the tidyverse. So if you are using that, that would be helpful. But yeah. Yes, absolutely. You can also put the warning code first. For sure. Any other questions that we can answer? Anyone written a cool function lately that they want to share? Good question. So what are philosophies on setting default values for arguments? You can if you want. So that happens in the, I'll just scroll up to the top here. That happens up top. So if you wanted to set the default to be, for example, C to F, that shows up when you call the function. So from C to F. But I did try this out last night because I was wondering how it would work. And the way you kind of have to, oh, actually, no, I can do this right now. You have to put the thing that that doesn't have a default first, and then you can use it with your default. So if you want to set a default argument or default value for your argument, all those arguments have to be after what you have to specify. And in terms of like philosophies, I guess my personal thing is that you can set it to be whatever you want, but the way that I usually go through my workflow, I usually explicitly, or I try to explicitly call arguments. So setting default values is not something that I tend to do when I write functions, but I wonder if other people have other thoughts on that.
And for your Planet Awesome function,
Mhm.
why do you have to start off by telling it that your X variables are characters?
Yeah, so that is sort of so that I can have this warning message. So if my argument is a character, then I know for sure that it's a class of object that can be put into this expression in the way that I've written. And otherwise it's gonna throw an error. So that's why the conditional is class X is a character. Does that answer your question?
And can you, in the vector of planets that you have above, can you like throw a number in there or something and see what happens? Just
Yeah,
as an
let's
example.
let's do that. Okay.
It's changing.
Oh, okay. Whoops. So it still runs, but if you run something like that, then it'll throw an error. So I think it is because, let's see what the class.
I mean, isn't it coerced into a character in that case?
Yeah, it is. It is coerced into a character. I guess now what I'm thinking is like in that first conditional, what you could do is go through each object within that vector and evaluate it individually to see if it's a character. But I I get nervous about subsetting in front of people, so I'm not going to type that. But that is something that you could do. Thanks, Maina. Anyway, this is all we've got for you. Remember that there's a published knitted HTML on archives, and we will post the recording of the session on our Google Drive. There's a learner tutorial if you'd like to see my silly planet illustrations. But that is it. Thank you all for coming.
And I have a question. Thank you so
Yeah.
much. Yeah. But it's not related with the functions. It's like I missed the first part, and I didn't understand why